Dear students, welcome to this online class. I hope you all are happy and safe at home. Have you revised your chapter areas related to circles? I hope that you revised that chapter and practice that worksheet also. In that chapter we learned area of a sector, area of a segment, length of an arc of a sector, and how to find the area of combination of figures. Today we are going to study a new chapter, surface areas and volumes. In the previous chapter, areas related to circles, we studied how to find the area of a combination of plane figures, that is, two-dimensional shapes. In this chapter, we will study about the areas of surface areas of combination of 3D shapes, that is the solid shapes such as cube, cuboid, cylinder, cone, sphere, hemisphere, etc. In class 9, we have learned about the surface areas and volumes of solid figures such as cube, cuboid, cylinder, cone, sphere, hemisphere. In our day-to-day life, we come across several solids which are the combination of two or more solid shapes. For example, a tent. It's a combination of cone and a cylinder. Your favorite ice cream, cone ice cream. Cone ice cream is the combination of cone and a hemisphere. A tanker. A tanker is a combination of cylinder with the hemispheres at both ends. Capsule. It's also same as cylinder with the hemispheres at both ends. Test tube. It's a combination of cylinder with the hemisphere at one end. Rocket. It's a combination of cylinder with the cone. And a top. You know what is a top? Yes, we are playing with this top, is it? It's a combination of cone and a hemisphere. So such way, so many solid shapes you can see in your surroundings. We shall discuss problems on finding surface areas and volumes of such solids. Before that, let us recall the formulas for finding the surface areas and volumes of solid shapes like a cube, cuboid, etc. The first one is cube. A cube has 6 faces, 8 vertices, 12 edges. Suppose the side of a cube is a unit, then the area of one face is a square because it's a square shape. Each face of a cube is square shape, so area of one face is equal to a square. Therefore, the area of 6 faces is equal to 6a square. That is the total surface area of a cube. And then what is the lattice surface area of a cube? The lattice surface contains only 4 faces. Area of one face is a square, then area of 4 faces is equal to 4a square. Then what will be the volume of a cube? We know that volume means capacity of the vessel. So volume we are measuring by base area into height of that vessel. So base area of this cube is a square shape. Its base area is equal to a square into height, that is a. So a square into a cube. So volume of a cube is equal to a cube. Now we can discuss about the cuboid. Cuboid has 6 faces and 8 vertices and 12 edges. That all things we know it. What is the total surface area of a cuboid? That we studied already. We studied in 9th standard. Anyway, let us recall. Suppose this is the length of the cuboid, and this is the height of the cuboid, and this is the base birth of the cuboid. Length, breadth, height. It's a cuboidal box. So this is the length, breadth and height. So area of this face is equal to, it's a rectangular shape. Area of this face is equal to length into breadth. Here length is equal to L unit, breadth is equal to H unit. And you are considering this face. This is a rectangular shape. The area of a rectangle is length into breadth. So this is length and this is breadth. So area of this face is equal to L into H. The same way the back side also same position, length and breadth is coming. So there also the area will be length into height. So you have two faces. These two faces areas will be length into height. That is L into H. Now you can see this side. Area of this face is equal to breadth into height. That is B into H. The same opposite of this face here also breadth into height. And then next top and bottom area. Here top area, this is the length and this is the breadth. So here length into breadth, L into B. That bottom also it will be length into breadth, L into B. So the total surface, now we know the area of each faces. Here it is length into height, length into breadth, length into height, length into breadth, breadth into height, and here also breadth into height. So total surface area of this cuboid is 2LH plus 2LB plus 2BH. So total surface area of a cuboid is equal to 2 into LH plus BH plus LB. And what is the lateral surface area? The lateral surface means these four faces. So face 1, 2, 3 and 4. The area of these four faces. So 2 length into height and 2 breadth into height. That is 2 LH plus 2 BH. That is equal to 2 into LH, 2 and H is common. So 2H into L plus B. That is the lateral surface area of a cuboid. Then what will be the volume of this cuboid? We know that base area into height. Volume is base area into height. The base area is a rectangular shape. The base area is equal to length into breadth, L into B. Into base area into height. Height of this cuboid is H. So L into B into H. That is the volume of the cuboid. Now we are talking about the cylinder. A cylinder has 3 faces, 2 circular faces and 1 curved face. This total surface area of this cylinder is this circular area plus curved area plus this circular area. 2 circular area plus 1 curved surface area. So first of all you want to know the curved surface area of a cylinder. And we know this is the height of the cylinder and this is a circular shape, so you will get the radius of the circle. This is the radius of the cylinder and this is the height of the cylinder. To find the area of this curved surface, we want to, when you cut this cylinder vertically, we will get a rectangular shape. We will get a rectangular shape. When you fold it, your cylinder, it will be in the cylinder. When you cut the cylinder, you are getting a rectangular shape. So the rectangle, the length of that rectangle is equal to the circumference of the circle. Length of this rectangle is equal to the circumference of the circle, and breadth of the rectangle, that will be the height of the cylinder. So we know that area of the rectangle is length into breadth. Now the length of the rectangle is equal to the circumference of the circle, and height of the breadth of the rectangle is equal to the height of the cylinder. So the area of this curved surface area of cylinder is equal to CSA. Curved surface area of a cylinder is equal to area of this, equal to the area of this rectangle, that is length into breadth. Length is equal to the circumference of the cylinder, circumference of this circle. that is 2 pi r into height or breadth. The breadth is equal to the height of the cylinder. So curved surface area of a cylinder is equal to 2 pi r into h, that is equal to 2 pi r h. So if we know the curved surface area, we can find the total surface area of the cylinder. Total surface area of a cylinder is equal to area of two circular shapes. So we know the area of a circle, that is pi r square. So there are two circular faces, so area, total area 2 pi r square plus area of this curved face, that is 2 pi r h. In both the terms 2 pi is common, you can take it out. 2 pi and r is also common, you can take it 2 pi r out. Then 2 pi r into r plus h. That is the total surface area of a cylinder. Curved surface area, remember curved surface area means we are finding by when you are cutting the cylinder vertically, you are getting a rectangular shape. That area of the rectangle is equal to the curved surface area of the cylinder. Length of the rectangle equal to the circumference of the circle, and breadth of the rectangle is equal to the height of the cylinder. So 2 pi r into h is equal to 2 pi r h. Then total surface area is equal to 2 pi r into r plus h, where r is the radius and h is the height of the cylinder. Then what is the volume of a cylinder? We know volume is the base area into height. Here the base area is circular shape. The area of the circle is pi r square and the height is h. So volume of a cylinder is equal to base area into height. So pi r square h. Volume of cylinder is equal to pi r square h. Next solid figure is cone. A cone has two faces, a circular face and a curved face. And this is the radius of the cone, and this is the height of the cone, and this is the slant height of the cone. We know that the curved surface area of a cone, that is equal to pi r l, where r is the radius and l is the slant height. And what is the formula we are using to find the slant height? We know that this is the right circular cylinder, so this angle is 90 degrees, so this is a right triangle, and this is the base, altitude, and this is the hypotenuse. So hypotenuse is equal to square root of base square plus altitude square. So n is equal to square root of r square plus h square. And total surface area of a cone is equal to curved surface area, that is pi r plus base area or the circular area, that is equal to pi r square. In both the terms pi r is common, you can take it out. Then pi r into l plus r, that is the total surface area of a cone. Pi r into l plus r, where r is the radius and l is the slant height, and h is the height of the cone. Then what will be the volume of cylinder? Last year we studied the volume of volume of cone. We know we've done one experiment last year. We know that volume of cone is 1/3 of the volume of cylinder. So we know the volume of cylinder, that is pi r square h. So volume of cone is equal to 1/3 of that volume of cylinder, that is 1/3 pi r square h. Volume of cone is equal to 1/3 pi r square h. Next is a sphere. We know that a sphere has only one face. The area of the or total surface area of the sphere is equal to how much? Total surface area or surface area of a sphere is equal to 4 pi r square. Total surface area of a sphere is equal to 4 pi r square. Then next one is a hemisphere. You know that hemisphere is the half of sphere. This is the radius of hemisphere, and this length also is the radius. So a hemisphere has two faces, a circular face and a curved face. So the area of the curved face, that will be the half of the sphere. Area of sphere is 4 pi r square. So area of hemisphere, so curved surface area of a hemisphere. The curved surface means only the half part of the sphere. So curved surface area of a hemisphere is equal to half of the area of the sphere, that is 2 pi r square. And it has two faces, so total surface area is equal to curved surface area plus base area, that is equal to total surface area is equal to 2 pi r square plus pi r square, that is equal to 3 pi r square. So total surface area of a sphere is 4 pi r square, total surface area of a hemisphere is 3 pi r square, and curved surface area of a hemisphere is 2 pi r square. Then what is the volume of a sphere? Volume of sphere, we know, volume of sphere is equal to 4 by 3 pi r cube. And volume of hemisphere is half of that. That means 2 by 3 pi r cube. Volume of sphere is 4 by 3 pi r cube. Volume of hemisphere is equal to 2 by 3 pi r cube. Next is a hollow cylinder. We know the surface area of a cylinder, solid cylinder, that is curved surface area is 2 pi r h, total surface area is 2 pi r into r plus h. When it is a hollow cylinder, what is the area? You know, it's a hollow cylinder is an example for pipe. If it is a hollow cylinder, what will be the area of this, total surface area of this hollow cylinder, and what is the volume of this hollow cylinder? So it has outer curved face and inner curved face, and its cross section. This section is known as, this part is known as a cross section. And what is the area of this cross section? Here we know that the radius of the outer curve is capital R, and radius of this inner curve, inner cylinder, that is small r. So the thickness of the cylinder, this yellow shaded region is the thickness of the cylinder. That thickness of the cylinder is equal to thickness of the cylinder is equal to capital R minus small r. Radius of the outer cylinder minus radius of inner cylinder. Then what is the area of this section? Area of this cross section. Here, area of cross section is equal to area of this big circle minus area of this smaller circle, that is the area of the shaded region. Area of big circle minus area of small circle, that is pi capital R square, that is the area of the outer circle minus area of inner circle. Pi is common, you can take it out, then it will be pi into R square minus small r square. This is the area of the cross section. And what is the area of this outer curved surface? The outer curved surface area of this hollow cylinder is 2 pi r h, that is the capital, radius will be capital R. 2 pi r h, outer area. Outer curved surface area is equal to 2 pi capital R h, and inner curved surface area, that is the inside part, inner curved surface area, that is equal to 2 pi small r h, that is the radius of the inner part is small r. And what is the total surface area of this hollow cylinder? We know that the total surface area is equal to this cross section area, to area of cross section plus area of outer curved surface area and inner curved surface area. We know that outer curved surface 2 pi RH plus inner curve, that is 2 pi RH, plus these two cross sections. So here the area of this cross section is pi into r square minus r square. So there are two ends are there, two circular cross sections are there. So 2 pi into r square minus r square. So total surface area of the hollow cylinder is equal to 2 pi capital RH plus 2 pi small RH, that is outer curved surface area plus inner curved surface area plus area of these two cross sections, that is 2 pi r square minus r square. This is the total surface area of a hollow cylinder. Now the volume of this hollow cylinder. We know that volume of a cylinder is pi r square h. Here we want to get the volume of this hollow cylinder. That means this part, this area, volume only you have to find the volume of this. So volume of hollow cylinder is equal to pi capital R square h minus pi small r square h. Volume of outer cylinder minus volume of inner cylinder. That is equal to pi h is common, then pi h into r square minus r square. That is the volume of hollow cylinder. Today we discuss lateral surface area of a cube, total surface area of a cube and volume of a cube. Then cuboid, lateral surface area of a cuboid is 2h into L plus B. Total surface area of a cuboid is 2 into LB plus BH plus LH. And volume of cuboid is equal to length into breadth into height. Next, cylinder. Curved surface area of a cylinder is 2 pi RH. Total surface area of a cylinder is 2 pi r into r plus h. And volume of cylinder is pi r square h. Cone. Curved surface area of a cone is pi r L, where L is equal to square root of r square plus h square. Total surface area of a cone is pi r into r plus L. And volume of cone is 1 by 3 pi r square h. That is the 1/3 of the volume of cylinder. Next is sphere. Total surface area of a sphere is 4 pi r square. And volume of sphere is 4 by 3 pi r cube. Hemisphere, that is a half of sphere. Curved surface area of hemisphere is 2 pi r square. Total surface area of hemisphere is 3 pi r square. It has two faces. So the total surface area of hemisphere is 3 pi r square. And volume of hemisphere is 2 by 3 pi r cube. So children, you have to write and study these formulas and practice well. You have to write this summary part in your notebook and practice the worksheet also, that I'll send it in the parent eye. Thank you.